Okay. Okay. Ladies and gentlemen, let's go ahead and get to it. Thank you for coming. It's a new week, a fresh week. How are you feeling? You submitted homework 3, right? It wasn't too bad, I hope. Okay, I'm going to get your thoughts on that a bit more in just a bit. All right. But before we get going, I got an engine to show you. Okay, it's an engine that may be familiar to you. Okay, and we're going to check it out really quickly here. 1993. Let's go. Your favorite company? Okay. Who's seen this game before? Right? Okay, notice, I can shoot the enemy on top of the ledge, but I'm not even pointing at that enemy. See it? Okay, so you've all heard that game before, right? The famous tunes in that first stage. You've seen the game before. It has kind of a distinctive look. When that game came out, right? When that game came out, Doom, it really did look like nothing that had pretty much ever been seen before, okay? In an interactive form. 1993, it was the creation of the famous studio id Software, and it really changed things. It kind of spawned a new genre, the first-person shooter, the most dominant genre in all of gaming today, okay? And it was also really interesting, kind of from an engine perspective, in that it was an engine that really had to deal with some very difficult technical hurdles, okay? This is an engine that came out on computer hardware that looked like this. Okay? Yeah, this was made for very slowly showing you crappy bar charts and spreadsheets. And that was kind of it. Okay? It was not super fast. It had a lot of difficulties. And getting that to work was a humongous technical challenge for the team. In many senses, these very expensive computers, right, many thousands of dollars in some cases, were worse at displaying games than the cheap $200, $300 NES consoles of the time, and the Super Nintendo consoles and stuff like that. So getting everything to work was very difficult. I can't really explain exactly how they did it, but they made very good use of data structures to speed things up, to accelerate things, and a lot of clever math. And there's actually a GitHub repository for this engine. This famous engine, it is open source, though if you get it to build, you also need to actually buy the content to run the original Doom with it. You can't just build this and then run Doom. You need to also buy Doom so you can get the content somewhere. But you can look through it. You can get some notes from John Carmack, the author, the main author himself, and some interesting stuff there. This engine, when you look at this engine under the hood, a lot of elements of this engine and how you design this engine are 2D. And that partly explains, for instance, why I was able to shoot, right? I was able to shoot basically straight at a wall, and the enemy that was way above me, right, on a cliff got shot, took that damage. And so what we're looking at here is kind of an overhead view of the map, but this is kind of how you would make the map. This is called Doom Ed, I believe. This sounds like an educational computer game, but no, it's Doom Editor. And so you've got a map editor. You also have a thing inspector. So we use the theater. We use the theater motif for naming our concepts. Here, a game object is kind of a thing, all right? And that's how it is. But you've got some basic tools in here for kind of texturing stuff. There was a lot of compilation that you did to kind of get this all into a form that would execute quickly. And this is also, interestingly, you've heard of the early Apple computers, right? You've heard of the early IBM PCs. Have you heard of the Next workstations? No? Okay, a couple of you. Okay, what were the Next workstations? Anyone?
Weren't they just kind of I know Steve Jobs got fired from Apple, so that was his next venture. And it was kind of his spin-off to attack Apple or something.
Yeah.
This is kind of he had a lot of inspiration from Windows to start this Next GUI thing, so that he can be bought by his own previous company and be reinstated as a CEO.
So Next, I recall, was one of the companies that was kind of driving OOP in some of the early days. In fact, if you go and write Objective-C, how many of you have done that? Objective-C, you've been in Xcode. You'll see a lot of data types, and I think even functions that start with NS, right? And I believe that stands for next step, because a lot of those technologies were developed at Next, Steve Jobs' company. So they were purchased, and a lot of those technologies were brought on to the Apple side of things. Anyway, I think those machines had higher resolution, nicer monitors. I think they were generally pretty good hardware for their cost at the time, but they didn't really take off, and I can't remember exactly why. But anyway, there's a lot that you can do to learn about this engine and to learn about Doom and the creation of Doom. There's a very good ebook that's totally free online, the Game Engine Black Book on Doom. I'm still looking through it, and as I look through it, I'll get more and more details for this game engine of the day. Maybe one day we could even get some of the stuff running for you. But there's just a lot of really good stuff in here. I encourage you to check it out. Some advice from John Carmack. I'm not sure what I put here. Oh, yes. Okay. There are often trade-offs that can be made that gets you a significant advantage in exchange for limitations that you can successfully cover up with good design. So something that's going to be recurring in this course, and something you're going to start to feel as the homeworks roll on and get more interesting as performance becomes a bigger deal, what you'll discover is that if you can add a few constraints, just a few tiny constraints to your engine, to your gameplay, you can really speed things up. You can simplify your code, and you can get a lot of value out of that. But if you want things to remain perfectly general, you're going to pay the price. You're going to pay the price in performance, and you're also going to have to write more complex code to deal with that, okay? And you're going to get a feel for that pretty darn soon. In fact, the fact that we are in a grid world on homework 3, 4, and 5, what does that mean for your collisions? Anyone know what that means? What did you do to check collisions on your homework 3?
I just checked the distance absolute value, and if it was less than 1, then it was next to each other, and then if it was the same grade spot, it would
Okay, yep, you can do that. Anyone else?
It created a Boolean array with collision map.
Big Boolean array, okay. Is someone at this location? Yep. How easily can you do that if it's not a grid world? There's actually an infinite, kind of continuous world. Just use an infinite array, no big deal, okay? No problem. All right, anyway, you're going to get a feel for that advice and how true it is pretty soon, okay? Look forward to it. Okay, we did start the Twitch stream. Yep, we did, absolutely. Some announcements for you. The Get a Job Guide is here for you, okay? I'm not sure if you were at the Stardock recruiting talk at IGA Ann Arbor last Thursday, but it was a really great talk. If you don't know about this guide, it's right there on the top of your Canvas page. It's right here. And if you are really trying to get a job in the games industry, first of all, it's a difficult time for that. I do wish you good luck. But this guide has a lot of tips for things that you can do, okay? Tips, for instance, right, on your resume, not only having projects, but also listing the skills and tech you used to build things on that project, very important. Some of these are like dedicated to certain companies. So Stardock, as it turns out, really wants you to put tons of C++ stuff on your resume for when you apply to them, blah, 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 all these companies, blah, blah, blah. One really big one is academic opportunities. There are a lot of labs here at the University of Michigan, and if you work at these labs, if you apply for them, right, if you go and you make awesome Unity projects for them or Unreal projects for them, you can get a letter, which makes it much easier to get into grad school, and you can also get some good pay sometimes, and it's not a bad thing to do over a summer, okay? It's kind of like a academic internship, you can think of it as. Anyway, there's a lot of really cool labs and projects all over campus. And so if the job market, the commercial market, is proving a bit tough, right, then consider applying to some of these academic opportunities. I don't think you'll regret it, okay? All right, so just keep in mind this guide is here. Look through it. It's a lot of advice, and hopefully it'll help you out, okay? All right. Oh, yes, by the way, yes, when you're finished with this engine, please do consider putting it on your resume. Like, we do a lot of game dev stuff on this campus, but we don't do that much C++ game dev stuff. And it really did strike me on Thursday that, yeah, we really could use more of that. And so, anyway, in 4 to 5 weeks, your engines are going to have some pretty weird stuff going on. Some pretty interesting stuff. SDL integration, you're going to be hosting Lua, and thinking about data-oriented design to speed everything up. Okay? So it's going to be worthwhile to list this stuff in about 4 to 5 weeks. Okay, some advice. Unless you're a glutton for punishment, try and not use any spaces or white space of any kind in your file paths. I think a guide had like a screenshot where that was happening. Try and avoid that because it makes everything more complicated if you roll with spaces in your file paths, okay? It can break a lot of tools, and it's not great. Be careful about premature optimization. I've heard from a lot of students, or some students, who are already creating interesting data structures to really speed things up. That's awesome. It's fantastic. Go for it if you want to. But know that in general, prematurely optimizing before you run into issues with lag or performance can get you into some trouble, right? Every line of code that you write can contain a bug and incurs a maintenance cost, okay, an ongoing one often. And so you want to be careful, right? I would tell you to please optimize for elegance, please optimize for scalability at this time, and wait until you hit a performance issue, and then you can go back and think about how to resolve it. Your engines aren't that big. Refactoring won't take that long, and that's my advice for you right now, okay? Minimalism and elegance is probably going to be the best for you. How was homework 3? How did it go? How did it feel? I got some of your feedback via the extra credit feedback form. I appreciate that a lot. Do you have any other thoughts? I know like the order of updating actors confused a lot of people. It's just in the order of the array, almost always. Yes?
I've never used Makefile or Linux, and the
Okay.
felt a little wanting.
Okay, got you, right? So Makefile, Linux, all that stuff. Yep. So the cool thing about doing this in the first assignment is that now you've kind of got your footing. Your engine is working in all 3 platforms, and you shouldn't have to do that much to get it working with each subsequent homework. It's already working. The big thing is you might have to add additional dependencies and additional files, which it'll mean you need to revisit those platforms. Hopefully it's not going to be too bad though, okay? So hopefully it won't be too bad. That friction will begin to go away. You'll get better and better at dealing with these problems. Any other thoughts on homework 3? Yes?
So I guess when I was doing homework 3, I was able to use Make on my Mac as well. Is that going to be the case for all the assignments going forward? Am I going to have to rely on Xcode? Like I could just compile.
Oh, yes.
I could compile.
Yeah, so you will need to use Xcode. And the reason is because the autograder requires you to use Xcode.
Well, yeah, I mean, just if I want to run it on my own computer,
Maybe.
maybe.
Yes. So there are certain dependencies later that the autograder already has set up for you that you'll have to get installed on Mac if you want to use them and build. The reason that we require Visual Studio, Xcode, and Make on the platforms that they're on is because we want you to learn those 3 platforms. You could very easily end up at a Visual Studio house, and knowing how to navigate that UI and how Visual Studio works, it's a big deal. Okay, that will really help you move fast right away. Same thing with Xcode. You could end up in a team where everyone's using Xcode. Everyone else is going to be confused. Long onboarding process, but you're going to be in shape. Okay, good to go. And same thing with Make. Okay, in reality, what you probably eventually want to do is you want to move to something like CMake, which is a project that will basically generate all of the project files for all of those platforms without you having to go in and manually make them yourself, okay? But I want you to learn those platforms, so CMake ain't going to happen, okay? Maybe till the end. You can use CMake at the end if you want to, okay? Any other comments? One interesting thing is that there's a very big tendency to treat the player actor differently from any other actor. In a way, this is sensible, okay? It's natural. The player actor has some special logic associated with it. But I want you to think this might not always be the case, okay? At some point, we will want to be able to generalize all our actors and treat them all uniformly, okay? And that, so that's something I want you to keep in the back of your mind, okay? All right. A quick note on using office hours. In office hours at this course, excuse me, thank you. In office hours in this course, we can give you a lot more information than the autograder will give you, okay? We have reports that give us a lot of information about how your program did on a test case, okay? What it should have done, okay? What all the output looks like. And so please consider using office hours. That will really speed you up. It'll get you past a lot of those issues or maybe you don't quite know what's gone wrong. We can give you better hints and keep you moving, okay? A quick anecdote. When I was in graduate school, I was taking the Advanced Algorithms course. Great course, great faculty and staff. I had a special technique that made the course easier than it was for pretty much any other student. You know what I would do? The homeworks on this in this course were very, very tough. So what would happen is the homeworks would get announced. That night, I would go through the homeworks and I would try every single problem. I would have a attempt, a draft solution for every single problem. They were not good drafts. They were not good solutions, okay? So oftentimes I was just heading in the totally wrong direction. And the day after, I would go to the soonest office hours that I could, okay? I would go there, I'd be the only one there, okay? Because who's going to do the homework, right the day after it's released? That's crazy, okay? Well, here's the thing. There's no line, okay? I'm just there with the prof or the GSI or IA for, 60 minutes? And I've got attempts on every solution. So what happens is I was able to ask the professor, hey, am I going in the right direction? Here's my current solution. Am I thinking about the right thing? And they would never give me the answer, but they would always tell me, oh, you're headed, yes, this is right, this is the right direction, roughly, or no, you should be thinking about this algorithm or this data structure instead. Okay, so I would spend 10 minutes updating my draft, okay? And then I would ask them again, okay, I got this new approach. What do you think about this? And they'd correct me again. And within a few attempts of this, I basically know what the solution roughly is, and I'm finishing the homework that takes most other students 10 hours, 15 hours in like 3 or 4, okay? And it was very, very nice, all right? Okay, so this is all a tangent to say that please make use of your office hours. The better you do this, the easier your life will be. Be aggressive with it if you can, okay? And move as fast as you can, all right? The homeworks will get harder from here on out, all right? Not tremendously harder. I think it's kind of balanced, our incline, our difficulty curve, but you never know. So you really should start as soon as you can. Okay? All right. Last thing, it's almost a guarantee that at least one of you in this class will try and put your entire engine in one CPP file. Okay? If this happens to be you, know that you are technically not alone, just mostly alone. There's a game, an indie game called Thumper. It's very successful. And they have a GDC talk that I attended in San Francisco. You can actually find it online for free here. And the entire part of the talk is about how they built the entire game, many thousands of lines of C++ code in like 3 or 4 files total, and just a handful of functions, and with no significant use of like object-oriented concepts. Okay? And so, like, I guess you could say they just really wanted to focus not on making beautiful code, but on finishing their game. And it's hard not to respect that. If it worked for them, it worked for them. And they got the game out, and they made a ton of money. And so, I don't know. Maybe we shouldn't be talking, okay? Anyway, it's a really interesting story, a great thing to watch if you want to. And if you do it like this, you will also have the wonderful company of Yandere Dev, who writes code very similar to the code you'd be writing, okay? And so that's pretty good company indeed. So there you go. Okay, so if you look at the schedule here, we have a new homework launching. Just like the previous homework, it will be due in 7 days, okay? 7 days from now, just under 7 days from now. This is a homework that is kind of built upon the idea of modding, okay? A mod. What is a mod? Anyone play mods? Okay, right? Lots of you. If you don't know, a mod is when you take a game that's been released, a commercial game, and you change it. You go in there as the user and you mess with it, right? Somehow. Sometimes this is easy, right? When the game exposes a scripting language, right? When they give you documentation on how to mod the game, how to add content. When they externalize their assets, so you can find the 3D models on the disk, you can find configuration files on the disk. And sometimes, like if you're Nintendo, they make it very hard and painful to do this. But it is always possible, okay? It's always possible unless maybe you're playing like a Stadia streaming game, okay, or something like that. And so you're going to be making your text adventure game into a moddable text adventure engine this week, okay? If last week was about making a game and being a game dev, this week we're finally stepping toward being an engine dev. We're making an engine where expressiveness, creativity, flexibility is the name of the game, okay? And so we're going to talk about that. We're going to launch that homework today. And then we're also going to talk about the topic of some kind of basic memory matters, okay? Because as you get deeper into this course and the homeworks, how you store your objects and how you reference and refer to those objects is going to become a much bigger deal on several axes, okay? The first, ease of use and convenience, right? Developer experience, but also later, performance, okay? And so we're going to talk about that a bit today too. All right, so let's go ahead and get to it. First of all, does anyone have any questions on any of this stuff? Questions, comments? All right, good. Okay, let's go ahead and talk about the homework, okay? Let's talk about modding, right? The wonderful world of modding, okay? Has anyone played Resident Evil 2? Right, phenomenal game, right? Should have won Game of the Year when it came out. Got robbed by Sekiro, absolutely robbed. And do you remember the part where Thomas the Tank Engine comes around the corner and attacks you? I love that part. It's like my favorite part. Beautiful, right? Okay, so let's talk about mods, right? We're moving from hard-coded content, right, where the game designer, where the game developer is the only one deciding what will happen, what the characters look like, what they do, how they move, where they are, how many there are, to an environment where there's a lot more freedom for our users, okay? Last week, right, we encode all of our data into the code itself, into the C++ code, the source code, okay? Something to note here is that, hey, it's not that hard to edit this stuff, right? But remember, there's a very good chance we're not giving our end user our source code. Okay? They don't see this. We are the ones who see this. Okay? The end user is only seeing ones and zeros. All right? And it's going to be much harder for them to do a mod of this game if all of our content is kind of baked in to our C++. Okay? It's going to be a huge pain. This week, we are migrating our content out of the C++, out of our engine core. We're externalizing a good bit of it, okay? And we're going to be making scene files. You'll have multiple scenes, okay? And these scene files are where we will define where all of our actors are, what their names are, where they are they blocking, what do they look like, what do they say, okay? Stuff like that. This is moddable. This, the end user, will be able to literally see these files on their desktop. And they'll be able to open them up in Notepad++ or TextEdit or Visual Studio Code, whatever text editor they got, and they'll see stuff that's human readable, that makes sense. And when they change it, it'll actually change the game that they're playing. Okay? And so that's how it's going to be. What's the point of this? Why would you bother? Ravi?
Well, if you tell an artist to install Visual Studio, somehow they don't like you very much anymore.
Yeah, you tell an artist, you tell a game designer to install Unity or Visual Studio, yeah, they're not going to be very happy. There's a very good chance you're going to lose them all, okay? And so, from a user experience perspective, this is a huge win, okay? This is going to provide a ton of freedom to end users. From a financial perspective, this could be a boon for our game. If people like our game, if they like its core, if they like its gameplay, like its genre, how it's set up, they might be playing this game for a long time, making their own content, sharing that changed content with each other. It could be a huge boon for your game studio, okay? Right? The fact that Thomas the Tank Engine was in Resident Evil 2, right, within weeks, within days of the game releasing, okay, this was a big headline. All right, wait, you think we can find it? Hold on, wait. Resident Evil 2 Thomas Tank Engine, IGN. We gonna get a headline here? Boom, IGN Southeast Asia, okay. Oh, here we go. That's for the latest Resident Evil game. Okay, Resident Evil 2. Yep, so, right, there's good publicity coming out of that kind of stuff, okay? All right, good luck, Nikhil. Ooh, look at that. Ouch. All right. Anyway, it's also a necessary step on the path to full expressiveness and flexibility. If you think about the path from a kind of hard-coded game to a game engine, we need to start step by step making things more expressive, okay? We start moving gameplay and we start moving content out of our engine so that they can be edited and altered easily by our users, okay? Eventually, we need to get our text adventure engine, right, all the way to something like this, okay? And it's going to take a few more homeworks to get there, but we will, okay? And I think you're really going to like it. But the objective here is to be customizable. So actor positions, the visuals you use for your actors, the physics of those actors in a very basic sense, whether they're blocking, what their velocity is, their motion, the dialogue and commands that the actors run. There's actually going to be a couple new commands this week you implement. One of them to change the current scene. So, for instance, you can have a door actor, and when you step onto the door, it warps you into a new scene. So you can actually traverse through a facility if you want to, back and forth, okay? Intro and outro messages, so you can kind of set the context and the narrative and the plot, okay? The big thing that might be a bit frustrating this week is that we're still stuck in the same genre, okay? We're externalizing a lot of things, but we're not externalizing everything, right? Eventually, we're going to have to find a way to externalize gameplay and logic, which is going to be a really, really fun assignment when we get there, but very tough assignment too, okay? So the logic here is not customizable. The rules of this genre and this universe and the controls and all of that are still what they are, okay? And we're gonna have to get past that eventually. It's still gonna look to some extent like this. It might just be way crazier, okay? This is one of your performance test cases toward the end of the assignment. And I'll tell you, okay, all right, all of your assignments were blowing the staff solution out of the water this week, okay? I want you to know that's not a mistake. I programmed it like that, definitely. And this week we're very serious about performance, okay? It might be tough to get all these points. This is a solution with, I think, 1 million actors in it. Updating collisions, doing all this very quickly, collecting dialogue, okay? It's going to be a bit tough. So you want to put some time into that, all right? Okay, some tips for you. You're going to want to start early. We said that last time. We're even more serious about it this time, okay? This week, you actually do have some semi-difficult performance test cases to deal with, okay? And I will be honest with you, when it comes to speed, I'm not the best at that, okay? But I think I did a better job on homework 4 than I did on homework 3. And so you might have to break a little bit of a sweat to beat me, okay? We'll see. We'll see. All right, yes, very, very, very gnarly. You're going to be using the Rapid JSON library. This is just a pretty awesome library to learn in general for your JSON-related needs in C++. It's pretty fast. It makes interacting with JSON pretty easy. We only really need a kind of a small subset of Rapid JSON's features, but just like GLM, this is another dependency that you'll have to add. Okay, it's a header-only library, so it's not going to be too bad. But you do need to get used to and get very comfortable with adding these dependencies to your 3 platforms, your 3 build systems, okay? You can read about Rapid JSON here. You can find tutorials here and some basic stuff. You can also ask GPT or AI assistants for some starter code, right? If you want to just get started quickly. And it seems to do a pretty good job with that. Yep, ask for relevant examples if you want. One really crazy, mind-blowing thing was when I had like a custom format. It was over the summer. I had a custom format in a weird text file, and I really didn't want to write a parser for it. So what I did was I copy-pasted a chunk, not even the entire thing, just a chunk of the file I wanted to parse into GPT-4, asked it for a parser in X language, I think it's C#. Boom, it worked perfectly, first time, okay? And I don't really enjoy writing parsers at all, and I don't want to waste your time with that, so I'm not going to be heartbroken if you do something similar, okay? All right, so remember your chain of help. Try and solve it yourself, 15 minutes. Then consider asking your AI friends and see what they can do for you, and then ask Piazza, and then attend office hours, okay? And yeah, the earlier that you start this project, the earlier you can run into problems. And if you run into problems with a lot of time to solve them, you're going to solve them, okay? The problems always happen when you run into the problem and there's 24 hours left and we're out of office hours. That's the worst situation, okay? Because then it's like we can't help you very well, right? Pretty much all day today I'm teaching, and so even if you ask a question on Piazza, I'm kind of helpless to help you, okay? So please start early. Makes everything a lot easier for all of us. All right, any questions on homework 4? I'll show you the assignment spec really quickly. Now let's see if we can find it here. The modding, the mod directed reading here. Mods and cheat codes in general have a very interesting history, a very fun and playful history. And as you might see them as something of a sideshow, like kind of a joke, haha, Thomas the Tank Engine. The battle royale genre, the most popular genre on Earth today, literally came from a mod, okay? Have you ever heard of a small game called League of Legends? Okay? Heard of Dota? That was a mod, right? I think a mod for Warcraft 3, I think. And this is a case that Never Knows Best, wonderful documentary gaming channel, makes, that mods really are, in many cases, the creators of true innovation in our industry, right? The AAA industry will stagnate, indies will just kind of be chilling, and then a mod comes out that does things differently, okay? Auto chess. Wasn't that a mod? I think it was. What was it a mod of? Was it a mod of League? A Dota again? They mod the mod? It's amazing. Yeah, so auto chess was also a mod, right? And so there's an extremely impactful history of modding. I hope you'll take some time when you're bored or just resting to watch these great videos. History of the Game Genie, kind of how it works. We might talk about that a little bit more on Wednesday. History of the Konami Code, the famous cultural mod, cultural cheat. And then there's interesting software out there like Cheat Engine that you've probably heard of before, okay? A warning, we don't use Cheat Engine in this course because the free default version almost everyone gets is adware. It starts just showing you ads. Not what I would have chosen. Cry Search is what you'll be using on the homework this week. Does anyone know? Has anyone looked at the homework? Has anyone done the hacking part of it? You do need to do that, okay? We will be checking. Here's the homework. The first part of modding is actually you making a mod of an existing game, okay? And the game that you're going to mod, all right, it's called Sonic Suggests, okay? And have anyone ever played this game? Okay, maybe I'll show you the intro here. Let's see here. It's a very wholesome game. It was made by Hideo Kojima. I don't know if you know that. Let me see here. Let's see if I can extract all this right here. It has the finest gameplay. A story you won't believe. I should have given you like a horror game. I should have given you Greek tragedy. That would have been funny. Hack my own game.
Sonic, how are you?
Okay, gameplay begins. I wonder what the creator would think if they knew, like, a university was using this. Like, seriously. That's a Grand Theft Auto line, if you're curious. This game has a vibe. I actually really like it. I wish it was longer, though. The game's about 5... I told you. The game's about 5 minutes long. So... Alright, so... You know, it's a Sonic game. Okay? And your mission, should you choose to accept it, then you'd better, is to make this number say at least 500. And I'm going to give you a hint. There aren't 500 rings in this total game. Okay? And so, you need to make it say 500, and I wish you good luck to you. Okay? You'll be modding this game, and the assignment spec will help you figure out how to do so. Okay? And have any of you done anything like this before? Okay? Just a couple of you. I think it might be eye-opening just how easy it actually is, okay, to make this change, okay? Anyway, that's what you're going to do, and you're going to take a screenshot. You post it to the exhibition channel in the Discord to impress all your friends with your gaming accomplishment. And then you're going to get those points, okay? Or to be more accurate, you won't get penalized at the end of the grading period, okay? All right, then what you're going to do is you're going to go through, and just like last week, you're going to start upgrading your engine to, at first, have custom intro and outro messages. Okay, you're going to read that from disk. You're going to read that from a resources/game.config file, okay? You will set up the ability to read a rendering.config file to customize your camera. Okay, how wide is your camera? How tall is your camera? You're going to add support for custom scenes. That's a pretty big test suite. Okay, lots of stuff to do there. You're going to add an actor ID system, and you're also going to add actor templates. Now, besides the final performance test cases, this might be one of the tougher, one of the tougher suites. Okay, how do you set up a template system? We'll talk about this a little bit more on Wednesday, but a template is basically equivalent to us as a Unity prefab. Have you heard of a Unity prefab? Or have you heard of a blueprint in Unreal Engine? Or a scene in Godot? Okay, this is basically what you're doing. You think of it as a class, and then you instance that class to get your actors. Okay, basically helps you reduce the amount of code that you're writing, the amount of config that you're making. Okay. You will be adding a new proceed to command that basically allows you to change your scene, okay? Change to a new scene, right? Unload all your current actors, load in all the new actors, and then do a fresh render, okay? And then you've got your fun integration and performance tests where we spam you with a bunch of really hard test cases, okay? And hopefully that'll be fun for you, okay? Not the world's most difficult assignment this week, but it is no slouch. Probably, I think it will be a bit more difficult than this past week. Okay, hopefully not by much though. All right, and if you get started, you'll be fine. All right. So, any questions on the homework? Okay. Yes.
When it comes to the modding thing, never mind.
What?
I'm just like, I'll think of it.
Okay.
I have a question about performance testing. So like, you know how in 281 that if you're just like 1.2 times slower, you get some points, but they're like only 80% of the points. Like, do we have a boolean about like how many points?
Yeah, it's just Boolean. It's cut off. So you can be up to 25% slower than the staff solution and still get full points. If you're any slower, you get nothing. Yeah. When I took 281, it was like that. So maybe they've softened up a little bit.
They did.
Yeah, they did. Yeah. Well, the good news is you only get that performance penalty applied if it's a long test case. So most of the early test cases, you don't have to really worry about performance. If you have a slow solution but you have perfect correctness, you're still going to get most of the points on this assignment. And that's the way it is with, I think, most of the assignments in this course. Okay. Any other questions? All right. I hope you have fun on this assignment. It seems like a lot of people enjoyed the first assignment. Let us know when the spec is ambiguous, but do please reread the spec. Okay. Try not to go forward before you've got most of the suites, your current suites test cases working. The spec ID, I think, does have everything you need, but maybe it doesn't emphasize everything you need in quite the right places. That's what I noticed. A lot of students would post on Piazza a question, and then before I could get to it to answer, they would post like resolved, I should read or something, which is, that's how it happens. Okay, but not always. Sometimes there really is an ambiguity in the spec, and I really appreciate it when you raise that. Okay, so we can fix it quick. All right, very good. Let's keep going. I want to talk, and this isn't a very long lecture, but I want to talk a little bit about memory. I don't think this is something that we talk about a ton. In 281, do you talk a lot about this? Memory, kind of where things are put, how efficient different containers are, the complexity for sure. Okay, do you talk at all about like pointer invalidation in 281? You do? Okay, a little bit. All right, so hopefully this will be somewhat useful to you. If it's not, though, let me know, and I'll fix it for next semester. My guinea pigs, thank you. All right, so let's talk a little bit about both of those topics. Okay, when it comes to managing your actors, this is going to become a more interesting thing as the semester goes on. In fact, Nikhil in Homework 7, I think, just changed the way that he's managing his actors.
Yeah, because in Homeworks 4 and 5, you don't create new actors in the middle of runtime, but starting in homework 7, you give your developers the little API to do so, so you have to prevent further invalidation.
Yes. So depending on the features that you give to your developers, your game designers, you really have to be very careful that they can't break your, the way that you're storing your actors, okay? So last week, you had basically an array of hard-coded actors, right? And it's very consistent, right? You got your Spartans, you've got your player at the end, you got some NPCs in here, some friendly NPCs in here before the player. And this is pretty much it, right? You're given a standard vector, and nothing really changes too much about these as time goes on, okay? This week, things are going to get a little bit weirder because you can now have different actors in there. You can have more or less actors in there, different numbers of actors, and they can be different actors going around and doing crazy stuff, okay? And again, last week your player was always at the end, so you could get away with just, I'm going to do everything related to the player last. This week, that is no guarantee. Your player could be at the front of the actors list, or the back, or the middle, and you need to make sure that you are dealing with that appropriately, okay? So it's all going to become more interesting as time goes on. In the future, you might need to do things like sort your list of actors in some way so that you can render them in the order that they want to be rendered in. Right? We're going to introduce the concept of a sorting order that's configurable so you can make certain actors appear and render above others, okay, on top of others. You might need to sort based on collision checking, so you can do that quickly, okay? You might need to break actors up into groups to make certain operations faster to do, okay? And one question is, well, what can go wrong when you do this? In this course, where your objects are is going to matter. You're going to need to think pretty actively about this, or you could get into trouble. You could introduce bugs in a subtle way that you don't expect. And you're going to want to do this for a few different reasons, right? You're going to have to think about, are my objects in one place, or are they actually in multiple? Am I accidentally making copies of my objects when I shouldn't? That's going to cause all sorts of trouble if you do, okay? You're going to have to think about, are my objects kind of contiguously allocated, or are they kind of scattered around the heap, okay, in random places? It's going to have a performance impact, okay? In fact, just the other day, I had to upgrade homeworks 4, 5, 6. Did I upgrade 7? I think I did. To make them contiguous, which gave me, I think, about a 20% performance increase across the board, okay? You're going to have to ask yourself, where are my objects? What environment is controlling my objects? Is it an environment or the host language, or the guest language that's managing and dealing with and manipulating our objects, okay? There's often a big performance difference there, okay? There are huge ramifications for your ease of use, for your ease of programming, the elegance of your code, correctness, and performance, okay? And we're going to talk about performance at a later date as it becomes more important on the later homeworks, okay? So let's talk about some challenges you're probably going to run into with your memory. Let's say you want to load in your actor objects, okay? And a natural choice for a lot of you is going to be, hey, let's just make a vector, okay? Let's just make a std vector, and let's start pushing objects we load in from the seed file into that vector array, okay? So here we got our vector of actor types, and we're just going to call it actors in the scene, the current scene actors, okay? And there they are, nothing too funky, okay? But let's imagine that you really want to move through these in kind of a sorted fashion. And in particular, you want to go through these in the ordering of the name, okay? You want to sort these by name. You want to iterate through these by name, okay? So what do? Well, one thing you could do is you could say, you know what, I'm going to have a second vector, and I'm also going to push my objects into that vector, okay? And if you want to go through those objects, you can do it this way. And I see a few people gritting their teeth, okay? And everyone else is kind of like, okay. Wait, who's like disgusted immediately? Not that many of you, all right? So I do need to give this talk, all right? Okay, right? So this is cool, right? if this is read-only data, like all of this, I guess this might be fine. But your actors are not read-only. The actors are going to change, okay, over time. They're going to move. They're going to do stuff. Okay, let's say that I really want to quickly know all of the actors that are at a certain position. So let's say, like, I want all the actors at grid coordinate 3, 5. Okay? How can we do that? Well, we could create a map, okay? Maybe an STD, unordered map, okay, for a nice O1 performance, constant time lookup performance, with a key of standard pair to that standard vector, and there we go, okay? So something like this, right? Okay, so, yeah, this is going to get you wrecked so badly, okay? But this is the kind of stuff that we're almost certainly going to see a little bit of, because it's only basically one character here that's going to mess you up. I've got a question for you. How many copies of Player exist? How many copies of Spartan 1 exist? Okay, how many? Look, I'm seeing 3, okay? And that's a big problem for you, okay? In most situations, a big problem. Yes?
You just have those as like pointers.
Yes, okay? So we got a big problem, right? Because we've got duplicates of all of our objects here. We got 3 separate copies, and this is a very big problem for you, okay? Because we have basically violated dry. Now, what is dry? If you've taken my other courses, you know what this is, so I won't shut up about it. Okay, what is it?
Don't repeat yourself.
Yes, this stands for don't repeat yourself. And it's this idea that when you start making copies, multiple sources of truth, you start to get yourself into some trouble, okay? Right? And one issue is that, for instance, if you say, oh, I want to collect all of the objects in the 13-9 cell, and it's because I want to move them, okay? All the objects in the cell need to move for some reason. It's a gameplay mechanic. Well, you can go in and you can alter this player actor, but unfortunately, you've got 2 other copies of that player that you haven't adjusted yet, and now you've got this horrible desynchronization, and it's going to cause some bugs that might take you a little bit to figure out if you don't realize you've got different copies, okay? Just kind of hanging out there, okay? And so, that's not good, all right? So one solution, right, is to have basically one kind of primary store of data and to kind of treat that as the source of truth, okay? In this case, we have our standard vector of actors, right? Scene actors. This is like the same as it was last time so far, okay? But instead, right, instead of making copies of those actors, what we're going to do is we're going to kind of manipulate them and we're going to sort them, but without making copies, okay? And the way to do this is instead of using a vector of actors, we're going to use a vector of actor pointers, okay? References instead. And this, well, it's basically going to look like this, okay? Now, we can mess with this array as much as we want, okay? We can sort it however we want to. We can do whatever we want. We can manipulate it, and we're not going to mess with or wreck the original data, okay? And basically, it's kind of hard visually to see, but if you have a sorted actors by name array, you can iterate through this array of pointers, and you can get things in the order of their name. So the first would be player, and then the second is Spartan 1, 2, 3, 4, and 5, okay? So that might be helpful to you. You're adding a layer of interaction, and you're maintaining pointers instead of a copy of the original objects, okay? This is dry and somewhat lightweight. Pointers are fairly small. Potentially actors could be gigantic, but pointers to actors are usually going to be pretty darn small, okay? And so that's helpful. What you could do, and one thing that I did on the my staff solution was I really wanted a reference to the player for convenience, okay? When I see a player actor being loaded in, I really just want a pointer that will always point me to that player actor so that I can run some custom logic if I need to, okay? And so what you can do is something like this, actor star, player actor, and then you can grab the reference to that particular actor in the array, okay? Now, there are some ways that this can blow you up, okay? We'll talk about that in just a little bit. But so long as this array doesn't get messed with, so long as it doesn't ever move, you should be in a pretty okay place. All right? And the good news is that only one copy of each actor actually exists. Right? And so that's a pretty good time. Okay? So here's some example code here. Right? You've got this kind of database of vector actors, right? And we're building a new array, and we say, hey, we only want all the even actors, okay? So we can iterate through that original database. We can check if the database is even, and if so, we can push a pointer pointing to that particular actor onto our even actors array, our vector, and then we can just print it out, and we now have a vector of only the even actors, okay? Without making any duplicates and all that good stuff, okay? In my code base, I just tend to use the little DB little thing. I'm not sure if that, I don't think that's standard at all, but it kind of gives me the idea that I'm basically defending and manipulating and storing this original primary data and kind of blocking how that can be messed with, okay? In my code base, you'll see, for instance, imagedb.h. That is a class dedicated to loading in images for SDL and basically defending those images so they can't be unloaded, they can't be messed with, they can't be moved, and providing views into that data via, vectors of pointers, okay? You can kind of think of this even actors vector as kind of an auxiliary convenience or view data structure that kind of gives you a special view into that data without messing with it, okay? Without altering it. And yes, this is what my code base on some of the later homeworks looks like. ImageDB, SceneDB, which kind of tracks a bunch of the actors and keeps that actor kind of data store protected so it doesn't get messed with. AudioDB for audio stuff. ComponentDB for messing with, or for storing scripts and stuff like that. And so there you go. Okay, you can follow my style if you want to, or you can go your own route, or you can put it all in one file if you want to. I don't care. You do not get graded on style. Okay, I was thinking earlier this morning, like, wow, we don't grade on style in this course. But wait a second, we kind of do. Because if you have a really terrible style, it's going to show up in your homework grades, probably by the time of homework 5 or 6 or 7. Okay? So we kind of do grade on style. Okay? Just not explicitly. Okay, so what happens if you, what happens, let's see here. Oh, you can sort the even actors. Like, that's not the right question. Okay, what happens if you sort the even actors right here? And I kind of answered it, right? You sort even actors. Let's say you want the even actors, but you want them in reverse order, okay? What happens? And the answer is nothing, right? You're just messing with pointers. It's not the original data, okay? You can mess with these pointers as much as you want. No big deal, okay? However, what happens if you sort the actors vector? What happens?
You've changed the order of them. So if, for example, you need to display the text in order as we did in homework 3, then you no longer have that order preserved.
Yes. You've got kind of a big problem, okay? Yes, you've lost the original order, but also all of these pointers, okay, right? If down here you decide to sort the original actors vector, you're moving those actors around. All of your pointers used to be pointing at the right things, but now they're not. You don't have a good idea, probably, of what they're now pointing at. You can kind of figure it out, and you might need to on a quiz coming up, okay? But in general, you do not want to mess with that original actors array, okay, with this approach. And by the way, that's partly why Nikhil switched away from the approach as soon as it became possible in homework 7 to add new actors at runtime. Riddle me this. What happens if, we got our actors array, don't worry, we're not going to ever sort it, okay? We got our nice kind of, we got our array of pointers to only the even ones, okay? And then we come down here, and you know what? I want to add a few more elements, just a couple. I want to add a few more actors into my actors array, okay? just adding a few actors. What's the no problem, right? What's the problem? My code doesn't work anymore. What's going on? Yes.
Don't vectors they like resize under the hood?
Yes.
They can move around the station field.
Yes, and that's one of the creepier aspects of taking this approach, in my opinion. It's very easy to forget about that kind of implementation detail, that as you add elements to a vector, you might trigger a move, okay? You might trigger a relocation of that vector to another place on the heap. It has to expand, but maybe there's not enough storage, and so it has to move to a new place, and as soon as that vector moves to a new place on the heap, you're in big trouble, okay? Very big trouble, because now none of your even actor pointers are pointing to what it used to, okay? And you can get yourself in big trouble, all right? So be very careful, all right? If you want to take this approach, then you need to be careful and you need to know about how this data structure is going to work and what it's going to do to your elements under the hood, okay? And that's kind of unfortunate, right? That feels like a code smell to me, because it's very easy to forget about that implementation detail. Ideally, you shouldn't have to care about how it's dealing with that stuff. But anyway, so yeah, the whole thing is just completely ruined at that point. Okay, if you just add a few more elements, everything is ruined. Okay, pointer invalidation is what has occurred. Your pointers, your underlying objects have moved from their original memory address, and you're in big trouble now. Okay, all right. So you can imagine, right? You can imagine a data structure that helps us quickly know in constant time, which actors are in a particular grid cell. Okay, and if you have something like this, that could be pretty nice. Okay, for instance, if you want to know, hey, maybe my player is in or about to jump into 17.2. So is there anything blocking in 17.2? Well, you can just quickly look and you say, oh, yes, there is something blocking in 17.2. Okay, that could be really nice for you. All right. But if you alter the actors array, like you remove from the actors array, or if you add to it, causing a relocation, or if you sort it, okay, now all sorts of awful things could be true. Okay, we've just done a sort, and then we've removed Spartan 4 and Spartan 5 at the end of our list. Our vector, okay? And so now everything is absolutely miserable, okay? It's a complete cluster now, okay? It's a disaster. And you might not realize it, until it's too late, until things start blowing up. So we now have two dangling pointers that are pointing to nothing, okay? Or we don't even know what's going on there, okay? They could be pointing to anything. And so that's not good. We also have somehow warped our player. Okay, so our player, right, has warped from 13.9, where they used to be, to 17 and 2, because now 17 and 2 is pointing to our player. Okay, and Spartan 2 has now somehow warped from 17 to 1.5. Okay, because now we got an entry in 1.5 of pointers pointing to Spartan 2. Okay. And that generally shouldn't happen if you're just sorting an array. They're warping around and being in different cell spots, right? And so we've got this horrible situation, compare and contrast how it used to be, okay? Sometimes it's possible to kind of fix things up after invalidating pointers, but I think in general, in these assignments, it's probably best for you to just avoid that kind of invalidation altogether, okay? But don't feel too bad about doing an invalidation when you're kind of switching between scenes. You're switching between scenes, which means you're trashing that array of actors in the first place, which means point invalidation just doesn't matter. You're not going to be using those pointers anymore. Clear everything, and you can load the new scene up, okay? And that should fix you up, okay? And again, right, a warning that you need to be careful as you resize elements in the vector. As you resize the vector, as you add to it, it will jump around in memory. You can avoid this if you use .reserve, okay? And this, if you know how many actors you're going to need storage for, .reserve should give you a small performance boost because you're basically telling the vector to resize to a certain size that you need without having it to kind of discover the right size as you go. And you will know how many actors you need because you'll be able to look at the .scene file and quickly gather that number, okay? And so that's kind of my advice for starting on this homework. In the discussion from last Friday, there was some advice, some syntax advice on rapid JSON. In the homework assignment, you'll find some sample code that can get you kind of going pretty quickly and loading stuff very fast. So I hope you'll use that. You'll look back on that discussion and it should get you going pretty quickly, okay? Get you to the fun stuff pretty fast. Does anyone have any comments or any questions? No? Okay, and this is actually something I need to know for course design. Like, how much of that was in 281? Or was it a useful review?
It was a useful review.
Useful review? Yeah? Good.
I think we kind of like covered this in some of the classes, but I think like going over it for this like particular project, how
Use
to
case.
help us in the use cases.
Awesome. Cool. Okay. My original solution before I went like last night and sped it up with this approach was to just throw things onto the heap, right? So just use new, place your actors on the heap. You get a pointer back immediately. And you can just store that in a vector. You can sort that vector. You can mess with that vector. It's not a big deal. And you kind of avoid this kind of invalidation by doing that. You do give up performance by doing that. Why do you give up performance by just using vanilla new?
It's hard to get to use like memory on the heap.
Yeah, right? So you're going to end up with a nice array. You're going to end up with a bunch of pointers to your actors. And you don't have to worry about messing with those or invalidating those pointers. But you're going to end up with your objects scattered kind of randomly around the heap, okay? And when you're iterating through those, it's not going to be all that performant, okay? You're going to have a lot of cache misses because, you have to read a bunch of memory to grab this actor, and then over here you have to read that memory again. You can't reuse that memory you read. If you keep your objects in kind of contiguous position, your cache is going to be able to load in more of those, okay? And it's going to be a bit faster. So that's a big topic for later in the course when we move into data-oriented design. And I hope you'll look forward to that, okay? But again, the takeaway here is just be very careful about where your objects are and about their potential to move around, okay, during this course. And you will have a much easier development time if you do this. Another big thing, try and make commits often. When I am working on the staff solutions, sometimes I'll introduce a bug, and the IDEs are just not very good at helping me understand what it is, okay, or what I did. Like some of these, Visual Studio is like an industry standard, and they're not always super good, even its error messages, at helping you understand what you messed up. If you have a recent commit, though, you have an easy kind of view, an easy list of all the guilty suspects. And if you need to, in an emergency, you just revert, forget about it, let's find a new way to get that functionality. Hopefully that won't blow up, okay? So make a lot of commits. And how many of you have like not used Git a whole lot before this course? I'm actually curious. Okay, right? Heck yeah, good. Getting more comfy with version control is going to be really useful for you, okay? I was talking with my friends at Stardock, and they're like, Austin, we had a few people some of your students interview, and they didn't know Git. It's like, what do you mean they don't know Git, right? 494 requires it, 498 requires it, this course requires it. By 498, I mean the XR course requires it. And they told me, no, Austin, they didn't know Git. So sometimes, like when you're on a team, you can kind of skate by a little bit, not knowing version control, not knowing some of that stuff. And hopefully that won't happen in this course. Okay. By the way, this is kind of the reason that we don't have teams in this course. I really want every one of you to make your own engine and go through all those challenges yourself. Now, I do want you to talk with your friends and peers about maybe some of the nice strategies you could approach, so long as you don't take each other's code or share code at all, okay? But it's going to be, in large part your engine still. Okay. Okay. Any questions or comments? Anything like that? Yes.
One thing that you could do to mitigate the resizing pointer validation is if you use indices instead of pointers.
Sure.
The indices will always use that valid.
Yep. So there are different ways that you can try indirection, and some of those will work pretty nicely. Gosh, what did I just do? I was just working on a class specifically for dealing with handlers, and this was inspired by Ravi, right? How you manage your components efficiently, your Lua components efficiently later on in homework 8. So we're going to get to that, building handlers and other interesting ways to not basically get invalidated. So, all right. I think that is all that I have for you. We got about 20 minutes, so I think I'll start office hours about 20 minutes early. I wish you all luck, and I hope you'll maybe take this time to get the new dependencies into your project, get it building on the autograder. That'd be a really good start, okay? And Groundworks for the Macs right across the hall. I'll be walking around to help you out, and we'll see you next time, okay? See you Wednesday.
No, it's not Austin. It's me.
What's that?
Oh, this is getting worse.
Oh. I wonder what's happened. Is it refusing to run your code? No, it looks like maybe there's actually an error. Hold on.
Talking about Robbie, they're all negative, so.
Yeah, so probably you're causing the autograder to fail in the loop. Okay. Yeah, it's true.
Yeah.
Okay, I'll take a look at it.
Does the office hours start for quick questions now?
Yeah, sure.
Okay. When you said that, you fixed your stuff, about having constant and access to positions last night, and you were improving on it. What was exactly the fix that you did? That still works on pointer validation. Was that the heap stuff or something else?
Oh, so I think you're talking about Nikhil changing his away from this, right? Is that what you're referring to?
Yeah, I'm still thinking about this data structure.
Okay, so unordered map, the idea is we have an X. We want to specify an X and a Y, and we want to quickly get access to all the actors at that location.
Mm-hmm.
Yes.
And
so,
this issue with pointer invalidation.
Yeah, so the issue with pointer invalidation, as soon as this scene actor's kind of core primary data structure gets sorted, and a couple things get removed, everything falls to shit. And it's a disaster. So we lose, suddenly we have a couple pointers hanging out.
Yeah.
We're still pointing at the same memory address, but now there's nothing there. And so we don't actually know, it's kind of undefined what's going to happen there. We could segfault, we could actually have some fake data there, or some old data. Another thing is that, let me see here. So we used to have the player in 13.9, and we know the player's in 13.9 because when we indexed into 13.9, we found a pointer that's pointing to the player. Now, however, after the sort, it's a big mess because when we go to 13.9, we're actually pointing to nothing. When we go to 17.2, we're now pointing to player. So player has somehow warped, from our perspective, from the cell 13.9 to the cell 17.2. When we know that's not true. That didn't actually happen.
So the fix to it, what's the...
How do you fix this up?
Yeah.
Well, what I would do here, first of all, I wouldn't bother. I would try and make sure this didn't get sorted.
It was immutable data.
Yes, basically. But what you could do is you could say, okay, everything's been invalidated. Let's iterate through the core array again. And we're going to say, and by the way, we're going to clear all this. And we're going to say, player is currently in 1915. So let's create a new entry in 1915 and put a link to the player.
Flush the stuff up and refill it.
And fix it.
Why can't you,
Wipe it.
if you're going to delete an actor, why don't you just get its X and Y positions and just do map of X comma Y dot and just find the player name and just delete it.
If you're going to delete That's kind of. I think that's a way you could fix it up.
That's what I did for one of my projects before. And that worked for the same time. There's a lot of times where I missed to do that, and I didn't know why it was still there.
Yeah.
But
that's the kind of code that I would not want to write.
Is
Okay.
it P342?
Yeah. That's what I can tweet before you kill me. But it worked.
It would probably work, but
Okay, but something should not work.
every line of code you write potentially has a bug in it.
Yeah.
So I'd prefer not to write that code if I don't need to.
Okay.
And also just kind of feels like
I think flushing and refilling is the most safe
Yeah.
solution where you have the control over the entire loop.
Yeah, if you have to do it, that's probably what I would do as well. But I mean, maybe you get to the point where flushing and clearing and refilling it and fixing it up is just not performant enough, and you just have to do this. But again, the best solution is just don't mess with that data if you can.
So and we know how many items will be by the scene time. I mean, that's the point, right? And then you can do research. So have them all contiguous.
Yeah. Now in later homeworks, you'll have to deal with
on runtime.
Actors getting removed and that's it's not that hard to deal with. It's just a little thing to think about. There's just a lot of tiny things to think about when you're programming all this. Nothing gigantic.
About this, I wrote a predicate in my homework 3 to do this.
Yeah.
Kind of using SCL's copy if.
Okay. Oh yeah.
And I feel like that was good enough for this case, but it's not as hacky as directly indexing into your data source to change things. Maybe that.
Yeah.
Also, I have a quick question. All the projects now the AutoCAD